Bonsuelum athletes, here we go. Lines, things of beauty, things that you will learn to love if you don't love them already. Again, as I've said before, you must first be able to know what makes something a line. So if something's a linear equation, you graph it using a shortcut. If something's not a linear equation, you don't use, none of this applies to stuff that's not lines, okay? So again, I just want to mention something. I'm going to scribble something on here, but don't you write it. If I give you this, don't start doing the stuff we're doing today, because this is an absolute value equation. You would graph that by an XY table until you can see a pattern and then draw it. And again, you should know it's going to be a V, but the main thing is, don't apply what I'm going to talk about today, okay? Because what I'm going to talk about today is for lines and lines only. Okay, before I say anything else, I want to make sure you understand something. Everything I'm going to say, everything, is going to have two exceptions to it. Those are vertical lines and horizontal lines. Okay, every vertical line has the equation x equals some number. In this case, it's like x equals 4, so it's a vertical line through x equals 4. If it was x equals -2, then you'd go out to -2, and you draw a vertical line through -2. Okay? Horizontal line. Every horizontal line has the equation y equals a number. So let me get rid of this because you don't need to draw that. You've already got the example you need there. So y equals -3. You go down to a y value of -3 and you draw a horizontal line. Everything, I don't care what it is, that I'm going to say from this point forward has those two exceptions. So if it's a vertical line or a horizontal line, whatever I'm going to say is not going to apply. You just have to have those memorized. Okay. Well, I've already talked to you about identifying a line, and I've talked to you about one way to graph a line. The only way I've shown you so far is by the x and y intercepts. I want to talk to you about a very important concept for a line, okay? And that's slope. And most of you think you know what slope is, and most of you are wrong, okay? Just so you understand that. But my 8th grade teacher told me this is what it is, and you know what? I understand it, so I don't want to think of it any other way. Well, if you think of it the way I'm about to say, you don't understand it. You think you understand it, and you don't. Okay, here it is. I've already told you not to use something in this class, and that's the word cross, right? There's no cross multiplication. Okay, well, here's another thing. This is garbage. Rise over run. Garbage. Okay? This is a lousy definition. It's a lousy definition. The longer you continue to think of it as rise over run, the longer you will not understand slope. You go, well, I can get all these problems right. Yeah, but you know what? Eventually you're not going to get them right. Maybe not this year, but next year. It's just a bad way to think of slope. What slope is this. First of all, you got to understand what slope is measured from. Slope is measured from one point to another point on a line. So I'm going to draw some stuff, okay? And you don't need to draw it, just listen. If you go from this point to this point and you measure the slope, that's fine. Say you go from this one to this one. Well, what if you measure from this one to this one? You'll get the exact same slope. What if you measure from this one to that one? You'll get the exact same slope. How about this one to that one? Same slope. How about this one to that one? Same slope. How about this one to that one? Doesn't matter. It's always from one point to another point on the line. It's from a point to a point. Okay? Make sure you're very clear on that. You're always going from a point to another point. And what is the definition of slope? The definition is the change in y over the change in x. And you're saying to yourself now, but Mr. Lieblang, that sounds an awful lot like rise over run. Whatever. It's not. It's the change in y over the change in x. Now let me point out something to you, and you don't need to write any of this stuff down. I'll tell you when you need to write stuff down. Just listen. Okay. You can change y up or down. It can be up or it can be down. You can change x up or down. But no matter how you change it, how do you find the amount of change? In other words, let's say you change y, I don't know, from, and just listen to this, let's say you go from 1 to 4. What's the change? Okay? Well, you can either take 4 minus 1 or 1 minus 4. I don't care. You just take one of them, subtract the other one, and you should take the absolute value, but remember, change. Anyway, I'll leave it at that. You just take 1 minus the other one. Okay, change in x. What do? You take 1x and you subtract the other x. Okay, it's that simple. So to find the change in something, you subtract. If I had $10 today and I have $12 tomorrow, that's a change of $2 because I take 12 minus 10, and that's 2. Okay? Now, for example, find the slope between points 7, -1, and -3, 4. Okay, what do? I take the change in y, so I take -1 minus 4, and then over the change in x. And once I go from -1 minus 4, okay, I hate when this thing does that. Okay, you have to go the same direction. So it's -1 minus 4 all over 7 minus 3. So it's always got to be, it doesn't matter which point's first, but it's always got to be in the same direction. You can't take -1 minus 4 and then go -3 minus 7. Okay, you can't do that. So it's -1 minus 4, 7 minus, sorry, did I say 7 minus 3? I apologize. That's 7 minus a -3. Okay? Now, what if you do this? What if you take 4 minus a -1 and then -3 minus 7? You'll get the same thing because you'll get 5 over -10, which is -1/2. It doesn't matter which point's first and which point's second, but it's always got to be, the same direction. Whichever one you pick first, it has to be the x and the y have to be the same for that first point. Okay, so it's pretty simple. You just subtract the y's, change in y, over the change in x. Okay, there are 3 types of slope. There's positive slope, negative, meaning you go up. And someone could say, well, doesn't this line go both up and down because it goes up to the right and down to the left? Yeah, but we read in this country from left to right. So I'm talking about as you look at it from left to right, positive goes up, negative goes down. Zero slope is flat, and here's where you have to be kind of careful. You have to be careful. Undefined slope means it's straight up and down. Now, this can also be called no slope. Okay? No slope and undefined slope are the same thing. It can be kind of confusing. No slope seems like it'd be zero slope, but no slope and undefined slope are the same thing. Okay, also note that a larger absolute value of slope means a steeper slope. So, for example, let's say you have a slope of one line is -5, and the slope of a second line is, 3. Okay? Well, 3 is larger than -5, but it doesn't matter because what you have to do is look at the absolute value of each of them. And since the absolute value of 5 is larger than 3, this M1 is a steeper graph. The only thing the negative does is tells you it's going down. Okay? Now, there are three typical ways that the equation of a line can look. All right? Three fairly standard ways. One of these, the first one, and the reason why I put it first is because it's the most important, you're not going to like because you're not used to it. And everyone's going to want to use the second one because it's the slope-intercept form. By the way, there's no such thing as y equals mx plus b. There's the slope-intercept form. You should call it according to its name. All right? I'm not saying slope-intercept form is not good. It's very good. It's very useful. But it's not, I don't think it's not the most useful form. Okay, the first one's called the point-slope form. Second one's called the slope-intercept form. And the third one is called standard form, which I've already told you about. Okay, now, eventually I'll get to how do you know which form you're looking at if you're not sure. Okay, in each of these equations or each of these forms that I've mentioned, the x and y, not x sub 1 and y sub 1, but just the x and y remain variables. So here, we have point-slope form. Now, take a wild guess. What two things does the point-slope form tell you about a line? Well, if you guessed it tells you a point and a slope, you're correct. It's amazing, isn't it? All right, so what's the point-slope form of a line? Y minus y sub 1, and there'll be a number in this y sub 1 equals m, and there'll be a number m for the slope times x minus x sub 1. So I gave you an example there of what it looks like. Now, what two things is that going to tell you? That's going to tell you a point, in this case negative 7 comma 3, and a slope 2/5. Okay, now here's the hard part. If it's y minus 3, why is the y-coordinate positive 3? And if it's x plus 7, why is the x-coordinate negative 7? I'll try and give you an idea, okay? And I'm going to scroll back up to what we did before with slope. Okay, up here, notice the points 7 comma negative 1 and negative 3 comma 4. Well, remember, what you do is you subtract the y-coordinate. So it's negative 1 minus 4. And if it's minus 4, why is it minus 4? Because the point had a y-coordinate of positive 4. So it's negative 4. Because it's the first y minus the second y. Okay, notice the bottom, the x's. We have 7 minus the negative 3, which you can look at it as like 7 plus 3. Well, why would it be plus 3? Because you're subtracting the negative 3. Okay? Now, if we go back and take a look. So look at this, slope is the change in y over change of x. If we go back and look at this point-slope form, all the point-slope form is the slope formula without fractions. Okay, what's the formula for slope? Slope equals the change in y over the change in x. I'm just not putting the sub 2 on the first one. Okay? And what do I do if I get rid of fractions? I multiply both sides by x minus x sub 1, and we get m times the quantity x minus x sub 1 equals y minus y sub 1. All this form is the slope formula without fractions. Okay? So, the part that usually confuses people is since it's x plus 7, you take negative 7 is the x-coordinate. And it's y minus 3, the y-coordinate is positive 3. Well, I tried to explain up above why you take the opposite. If you don't get it, please ask me a question. If we do, I'm going to go on. Okay? All right. So I'm just kind of telling you how to read the equation right now. Okay, let's take a look at the slope, and then I'll show you how to graph them eventually. Let's take the slope-intercept form. And that's the one everyone likes because it's the one, your 8th grade teacher told you or whatever. So what does it tell you? Well, its name tells you what it tells you. It tells you the slope, and it tells you an intercept. Now, which intercept? It tells you the y-intercept. So again, there's going to be a number where it says m, a number where it says b, all right? And you just pick them out and you graph it. So if we have y equals 2/5 x plus 29/5, okay, the y-intercept is 29/5, so it's 0, 29/5, and the slope is 2/5. Okay, standard form. And again, in a second, I'll tell you how you can know which form you're looking at. Notice the name doesn't really say anything. Up here, point slope, tells you the point, tells you the slope. Number 2, slope-intercept, tells you the slope, tells you the y-intercept. Standard, it doesn't, what does that mean? This doesn't tell you anything directly, but what you can figure out very quickly is you can find the x and y-intercepts. So for example, 2x minus 5y equals negative 29. I showed you how to do this the other day. The x-intercept is going to be 29 halves, comma 0. Because again, you stick 0 in for y, it goes away. And for the y-intercept, you stick 0 in for x, and it goes away, and you get 0, comma, positive 29/5. And I'm telling you, there's no easier way to graph that thing, okay? Am I ever going to say to you, you must graph it this way? Yeah, you bet I am. Okay, am I ever going to say that you must graph the slope-intercept form using the slope and the intercept? Yeah, you bet I am. Am I ever going to say you must graph the point-slope form by picking out the point and picking out the slope? Sure I am. Matter of fact, unless the instructions tell you otherwise, if I give you the point-slope form, that's the way you should be graphing it. Okay? If I give you the slope-intercept form, that's the way you should be graphing it. If I give you standard form, you should be graphing it by the intercepts. All right? Now, how do you tell what form you've got? Well, the point-slope form, it's kind of hard. You just have to recognize it. Okay, but this is what makes the slope-intercept form the slope-intercept form. Okay? Y is by itself. If I want you to write the slope-intercept form, you just get y by itself. Okay? Standard form. What makes the standard form the standard form? X and y on the same side of the equation. Okay? That's what makes standard form standard form. And let me just mention something else for reasons I'll get to in a second. It should not have any fractions or decimals. But the thing that makes it standard form is the fact that x and y are on the same side of the equal sign. Now, why can I specify, or why does standard form usually not have fractions or decimals? Following reason. Okay, let's take a look at the point-slope form. If you get rid of fractions, you no longer have the slope, so it's no longer point-slope form. Slope-intercept form, you get rid of fractions, you no longer have the slope, so you no longer have slope-intercept form. Standard form, it doesn't tell you anything directly. So you can get rid of fractions and decimals and it's still in standard form, and it just looks neater. It's just easier to deal with. Okay, now, what's an example of each of these things? By the way, before I actually show you these, let me show you something. These three equations that I've shown here, the examples, they're all the exact same equation, okay? They're just in different forms. If you graph y minus 3 equals 2/5 times the quantity x plus 7, and then you graphed y equals 2/5 x plus 29/5, and then you graphed 2x minus 5y equals negative 29, you would have graphed the same line 3 different times. They're just in different forms, that's all. And how do you change from one form to the other, I'll get to another day. All right? Okay, so let's take a look at some examples. All right, graph each of the following, and this is the way you should graph it. You should tell me there's a point, -5, 7, and the slope is a half. And that's all you need to tell me. So I'm going to plot out 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. You plot the point first because of slope. Remember, slope is always measured from a point to another point, right? So you need to plot the point first. And now I'm going to plot the slope of a half. Well, I can do that 2 different ways. I can go, and I'm going to just kind of draw a bunch of stuff on here and then I'll erase it. I can go up 1 and over 2. That's fine. But I could also do this as -1/2. Not -1/2, shoot me. -1 over -2, because -1 over -2 is the same as +1/2. So I could go down 1 and to the left 2. And it doesn't, you don't need to do both of these, by the way. Okay, remember, you only need 2 points for a line, and then connect up the line. Okay? Now, I'm going to draw some other stuff on here, so don't draw this just yet. I'm just going to kind of talk about stuff in general. What if I told you this? You have the point, so don't draw this. You have the point, I don't know, 1, 3, and let's say the slope is, I don't know, 2/5. Let's make it -2/5. Okay, so I'll go to 1, 3, and now I want to plot a slope of -2/5. So I'm going to go down 2 and to the right. 1, 2, 3, 4, 5. But could I also do this? Put the negative on the bottom and say it's up 2 and to the left -5. Sure, it doesn't matter. So I could go up 2 and over 1, 2, 3, 4, 5. And if you plot, and again, you don't need to do both those, you only need to do one. It's all going to give you the same line. This is not the one, don't be drawing this one, by the way, because this is not the one that I'm asking you to draw. I just want to point out, just like I can do on the example, 1/2 is +1 over +2, or I can do it -1 over -2. I can do -2/5 as -2 over 5 or 2 over -5. It doesn't matter. Okay, so let's draw the one then that I've told you. If you've drawn this other stuff, get rid of it because I've told you not to draw it. Okay? So I'm going to go over, I got to get rid of some other junk on here first. Okay, so I'm going to go over -5, 1, 2, 3, 4, 5, and up 7 to that point. And then I'm going to go up 1 and over 2. Or again, and that's sufficient. Or you could have gone down 1 and over -2 and put that. I don't care. And then draw it. That's how you should be drawing that. Okay, what form is this? This is standard form because x and y are on the same side. So let's find the x-intercept and the y-intercept. And by the way, do you have to tell me this and this? Yes, I want you to tell me how you're doing it. Okay, the x-intercept would be 4, 0, and the y-intercept would be 0, -12/7. And again, how did I get that? Well, for the x-intercept, I stuck a 0 in for y, leaving me with 3x = 12. For the y-intercept, I stuck a 0 in for x, leaving me with -7y = 12. And you should be doing that in your head. So we've got 1, 2, 3, 4, 0. Then -12/7 is -1 5/7. Just, get it close. So we have -1 5/7. Okay. And then draw it as best you can. All right. Okay. Let's take a look at this one. Okay, so the y is by itself, so the slope The y-intercept is 0, -3. And the slope is 1/2. How can this be? This is impossible. There is no way this can be. Why? You shouldn't even be thinking of doing this because this is not a line. This is not a linear equation. This is a quadratic equation. It's squared. So you should know that it's going to end up to be a u. Okay? But how do I expect you to graph it right now? You make an XY, anything else other than the line, you make an XY table until you're willing to bet me $1,000, you know what it's going to graph as. So, what am I doing? Okay, let's plug in 0 for x, and I'm not going to, if you need to calculate it, go ahead, but 0 squared times 1/2 minus 3 is -3. So I'm going to pick 0, -3. Okay, let's plug in 1. 1 squared is 1 times 1/2 minus 3 is -2.5. And if I plug in -1, I'll get the same thing. If you have any questions on this, ask me. So we have 1 comma -2.5. And -1 comma -2.5. Let's try 2 and -2. So either one of those squared is 4 times 1/2 is 2 minus 3 is -1. So we have 2 comma -1. And again, you should pretty much know that this is going to be a U shape. If you need to find more points, that's fine, but this should... remember, there are 4 things I said you should have memorized. Okay? What a line looks... The linear equation is going to look like a line. Quadratic equation, which is what this is going to be U-shaped. A cubic equation, that one I'm not that concerned with. And then an absolute value equation, which is going to be a V. Okay, so then just draw it as best you can. Oh, that's pretty bad. Anyway, okay. How about this one? First of all, it's a linear equation because it's variable to the first power. But remember, this is an exception. Don't start telling me the slope. Don't start telling me, anything else. It's a vertical line because x equals a number. Always graphs as a vertical line. So you just graph it as a vertical line through an x value of -2. And what have you done? You found all the values that can be substituted for the variables that'll make the statement true. Okay? If I take this first one, and I take any one of those points, I don't mean just the ones I kind of plot, I mean there's like the whole line. I take any one of them and I substitute it in there, it'll make that statement true. If I take any one of these points on number 2 that I've shown drawn, plug it into the equation, it'll make that statement true. Same with this one, number 3, and same with number 4. By the way, you'll notice I have kind of ignored the slope-intercept equation. I guess I could throw another one on here real quick. I could do y equals... I just figure most people are familiar with this. I don't know. Let's pick 2x minus 5. Okay, again, y is alone, and this is a linear equation. It's not like number 3 up here, because 3, yeah, y is alone, but it's not a linear equation. Okay, so on number 5, you have y equals 2x minus 5. So it's a linear equation, y is alone. So it's the slope-intercept, so it tells us the slope and the y-intercept. Y-intercept is 0, -5. The slope is 2. I'll just kind of draw a sketch here. It's probably not going to be very good, but... Okay. Okay, so we have 0, -5, which is down here, and then I'll go, slope is 2, meaning it's either 2 over 1, or it can be -2 over -1, and I don't care which one you do. I usually just pick whichever one you think is easier, so I'm going to go up 2 and over 1, and then draw the line. Okay? Again, I want to point out something. Deal with the equation in the form that it's been given to you in. And everything I've said has vertical and horizontal lines as exceptions. Remember, don't do this if it's not a line. But basically what you're going to do is if you recognize it as a linear equation, if it's given to you in a point-slope form, find the point, find the slope, deal with it. Slope-intercept form, find the slope, find the y-intercept, deal with it that way. If it's given to you in standard form, you have to calculate, but you should be able to calculate in your head very easily the x and y intercepts. Okay? So, in a nutshell, again, I don't expect you not to have questions. I do expect you to have questions, and I expect you to ask me. But that should pretty much be enough to get you at least started in graphing equations of the lines. I caution you, don't say to yourself, you know what, this is difficult for me, particularly with the point-slope equation. Don't say, oh, this is difficult. I don't know, I think it's hard. Okay, so I'm just going to go back and do what my teachers told me in 8th grade because, that was easy for me. Well, go ahead, and then it's like, I can ask questions that it's not going to do you any good to change the form. I want you to deal with it in the form that I give it to you in, unless I tell you otherwise. Okay? So if you're having difficulty with a point-slope form equation, particularly, ask me. Okay? If you get it straight now, it'll make the rest of the year a lot easier. And standard form, if you don't get this idea of finding the x and y intercepts, talk to me. Okay? Have a great day, everybody. What are we going to do next? Here, I gave you in these problems, I gave you the equation. You pulled the information out of the equation. Next time, I'm going to give you the equation. Sorry, I'm going to give you the information, and you're going to assemble it back into an equation. Have a great day, everybody.